Okay, welcome class. Today is the 29th day of June 2017, and we're going to take a seminar on non-parametric statistics. Our presenters are the wonderful doctors from Lagos State University, three of them. We're going to start with, like they say, ladies first, from Dr. Oyeduni Anigoro. Madam, but you have the floor to present non-parametric statistics.
Thank you, sir. Thank you, sir. I'm on.
You are wasting our time. You are wasting our time, please.
I'm on slide 2 now. Introduction. Once again, class, I'm presenting on non-parametric statistics. Introduction. Non-parametric statistics covers techniques that do not rely on data belonging to any particular distribution. That is, their distribution free, not a normal distribution, not randomized. Slide 3. The term non-parametric statistics was introduced in the statistical literature in the 1940s. The historical roots of non-parametric statistics are supposed to go back as far as the 1710, when John Arbuthnot did a study that included the proportion of male births in London using a sign test, which is a non-parametric procedure. The German's rank correlation coefficient is widely used today, and it was the forerunner of the chi-square test introduced in the 1900. Now, the assumptions for non-parametric, on slide 4 now, the assumptions for the non-parametric statistics. If the parametric assumptions, such as normal population, randomization, homogeneity of variance, are not provided, then
Yes.
parametric statistics, like 5.
Yes, we are waiting for you.
5 now. Examples of non-parametric statistics. They are many and varied. Analysis of similarities, Cooper test, and Whitley, chi-square, Kaplania. But for the purpose of this presentation, I want to concentrate on chi-square. Slide 6. Chi-square using SPSS. The research question is, will there be any statistical significant difference in the perception of male and female students on their likeness of the method used? Then we have the null hypothesis. There will be perception of male and female students on their likeness of the method used. Then slide 7, we have the mathematical model where x squared equals to summation.
Hey, hold on. Did you say x squared?
Oh, stop. X squared.
Yep.
X squared. Yeah. Where O is the observed, E the expected in that formula, in that model. Now I'm on slide 8. How to use SPSS for the statistics. This instead of procedures go to analyze, from there to descriptive statistics, cross-tabs, you transfer the variable set to the row box and like method to the column box. Then go to statistics chi-square, then go to cell, click on expected and observed, then OK, which will give you this thing. These are the cells I just listed now. These are the things that will happen from analyze to
Yep. We're losing you now.
From analyze after then the next on slide 10, procedure continues where you take it from you take the row where it should be, and the column where they should be. Then slide the procedure continues on slide 11 until you get to the point of okaying it. Then
I like that. Okay, in it. I like that.
12,
Okay. Yeah.
then on slide 12 we have the case processing summary. We have the case and the case we are considering is the set of the respondents and like method, whether they like method. What we have is 96% and the value, the missing 4%. And on the next now, the count, that's the observed count. We have 12, and the expected count, we have on the expected count, we have 13.3 for the male. For the female, we have that stated there. Then on slide 13, still explaining slide 13, we have the text on the row column. While on row, while we have the like method on the column, we have everything stated out there. Then this is the chi-square set, slide 14. Looking at this table, we're going to consider just the base chi-square. We are more concerned with that, which is giving us the chi-square value to be 0.52 at p greater than 0.05. Of freedom of 1. It means that it is not significant, so it's not like hypothesis is not rejected.
Good.
Then we move to the interpretation. The result in that table shows that there is no statistical difference in the perception of male and female students on their likeness of the method used. So our S square is 0.52.
Are you saying x squared again, madam? Are you saying x squared again?
Chi-square. Our is 0.5 at p greater than 0.05. Therefore, the hypothesis which states that there is no statistical difference in the perception of male and female students on their likeness of the method is not rejected. On slide 16, which is the conclusion. Non-parametric statistics helps to analyze data involving frequency count, opinion of people, and it can be used when parametric assumptions are violated. Thank you, sir.
Wonderful, wonderful. Yeah, you can see you have a lot of applause from the class. I like the concluding part, your concluding slide, which tells us when to use the non-parametric statistics, except you got some tenses wrong there. Non-parametric statistics help, not helps. And also, since you have non-parametric, there should be a hyphen between non and parametric. That is to show that there is not a combination of words, forming the adjective for the statistics. Anyway, very well done. I'm impressed with it. And we are opening up the discussion in class. We're going to go across the table that I have. There are, let's see now, 10 people in class with myself, making 11. So let me begin with Iroko Ganiu and then Joseph Amuide stand by. Yes, Iroko.
Yes, sir. On slide 4.
Yes, slide 4.
You made mention of the assumptions. And you said if the biological assumptions are not provided, then.
Yes. Are you still on, Iroko? Okay, Johnson.
My question is that Mr. Nicholas,
It's only when one of
By the way, Johnson, your picture is very, very good.
thank you, sir.
Yeah, very good. Wonderful. Yes, carry on.
So, Mr. Nicholas, I want to ask you, yes, aside using chi-square for what the work you did and the conclusion you arrive at, is it possible to use any of these ones mentioned in slide 5 for that same test?
Very good.
Okay, you mean the other types? Okay.
Yes, and we arrive at the same conclusion.
Yeah, let me answer that very quickly. You can't because they have different things that they are that you can apply them on. You can, for instance, use the Mann-Whitney U test. You can use the Kruskal-Wallis. You can use all of these ones. These ones they are all very different. It's the chi-square statistic that is correct for what she's doing. She's looking at percentages. If you look at Kruskal-Wallis or Mann-Whitney U test, we'll be looking at scores rather than percentages. The only thing is that the sample sizes are small, which will now make them not amenable to parametric statistics. So I've answered that for her. The chi-square is the only one that you can use for this particular analysis. Yeah. How much are you going to pay me for being your lawyer today? Yeah, well done, Johnson. But that's a good question, Johnson. That's a good question. We'll take Ari B and then Faith Omokara. Stand by. Yes. Larry is not yet set. Omoraka, Faith, you have the floor.
Thank you, ma'am, for the presentation. You mentioned other non-parametric statistics, and you move over to chi-square. Actually, I was expecting you to give us a little definition of chi-square when we are supposed to use chi-square. I think that is also important to this presentation.
Thank you. I thought she did that, but I mean, I'm sure she will give some explanation there. Saibu Olajide, you have the floor. Francis, stand by. Miriola Yonju, stand by. Okay, that's not on. Saibu is not set. Yes, Francis. Okay, Miriola Yonju. Stephen. Yeah, I think I've gone past.
Yes, sir.
Slide 13, yes.
Yes, sir. I would like us to explain more on the fraud time.
Yeah, there will appear to be some interference. All right, Madam. Okay, I'm taking her off now. Yeah, she's off. Yes.
Yes, sir. My question is on slide 13.
Good.
I'd like us to explain more on the cross application.
Next time I ask you to talk, Madam Miriola, you speak louder. I can hear you though, but it's not like you. If you hear Omoraka Faith is clear and loud. Yeah. Shino, can you still make an intervention?
slide 3. You talk about the history, man, and you were talking about it was first introduced
introduced the calculator in 1940s. Maybe you could tell us who was using it. So as not to have a hand when Wessis or Moraka and Mr. presented that we're talking about the origin. So maybe you could guide us who first introduced this in the 1940s.
All right. Maybe she did. Maybe she did.
Okay, sir.
No, you didn't get the joke. I'm sure she was not born in 1940. I mean, I said maybe she did. She was the one who introduced it. Yeah. So, Madam Oyeduni, you have the floor now. Please respond to the questions that are outstanding. Yes.
Okay. The like 13. He said I should explain the cross tabulations of looking at this table first. We have the
Yes.
and on that we have sex, male and
Yes.
then the like method is the response. So when you look at the observed count, you have the response.
Yeah, so we're going to move on to Lanre Aribi. Dr. Lanre Aribi, the captain of the class. So show leadership. You have been showing good leadership in terms of managing the class. So show leadership in terms of your presentation. So you have the floor.
Yes, sir. Thank you very much, sir. I think
Yeah, let me try to get 1 minute. Let me try to grab your presentation now. What timestamp do you say you have on it? 7:13. Okay, let me try to see 7:13. Yeah, okay. Dr. Larry, I found your slides. Let me just get them loaded. So here we go. Yeah. So please carry on. Carry on. Carry on, Larry. Yes.
Yes, sir. Okebukola is my name once again. Educational technologist and presenting a non-parametric statistics. In the past few presentations we have had in this class, we have been having parametric statistics. And we have been finishing the assumptions of parametric statistics.
Larry, your audio is not so good today. I wonder what's happening.
My slide 3 now. Non-parametric statistics. Data and the data is not required to fit a normal distribution. That means for the first assumption of parametric statistics, which is a normal population, normal population, whenever we don't have population in data, we have to use a non-parametric. Sometimes it's always called test as well, based on lesser. Whenever we have non-parametric, it does not mean that the people lacks factors. As we realize that when it comes to history to appreciate the person who first used the term non-parametric statistics. Definitely, as the previous presenter said, that he used since 1900 or the 1920s thereabouts. Non-parametric statistics have existed, but the term was not used until 1942 by Jacob Wolfowitz, who was a Polish American statistician. He introduced the term just to extend the then existing statistical theory and beyond the normal customary parametric framework. So moving on to slide 5 now, I have some common types of non-parametric statistics that have been used far and wide for various studies. We have the Whitney U-test, the Kruskal-Wallis, Wilcoxon, Friedman test. There are so many others as well, but I just have to get into this. want to focus on Kruskal-Wallis, chi-square, and Wilcoxon test. So Kruskal-Wallis test is a popular non-parametric statistics to compare outcomes of media among more than two independent groups. That is, when we have more than two independent groups, K greater than 2 means that whenever you have independent groups that are more than 2, then you have to consider using Kruskal-Wallis. The alternative parametric statistics to Kruskal-Wallis is the ANOVA. Definitely, we know the ANOVA as well. When you have 2 or more independent variables.
Yeah. We're losing you now.
But whether samples originate from majorly, that's what Kruskal-Wallis is meant for. The second one I'm talking about is the chi-square. The chi-square test. It is used to compare between observed and expected data. It is also used to test homogeneity, goodness of it, and independence of each group involved in the study. The third one I'm the Wilcoxon test. It's used to paired groups that have some similarities between themselves. Also, there's another evidence that 2 populations have the same continuous distribution. Moving on to slide 8, I have the information on how to use non-parametric statistics. Whenever you find yourself in a situation where your data standard statistical in the two, the decision rule, whenever your value, the value you get is less than or equals to the critical value from the table, you reject the null hypothesis. But thank God we have a package that has been able to help us calculate all this without checking it. Also, on the Kruskal, we used to compare chi-square from Kruskal-Wallis. How important themselves. My first point is that parameters for a particular and it's usually evaluate hypothesis for comparing services parametric and parametric. Let's go to slide 18. I gave out some examples on parametric statistics and their corresponding non-parametric statistics. So we are familiar with the one way and the back. And whenever you realize that assumptions of the one way and the back, it's always recommended. So we have the corresponding non-parametric statistics. I used a typical study using chi-square, and the title of my study is Perception of Stakeholders of the Educational Sector in Lagos State, based on their socioeconomic status and transit level. Now, the purpose of the study is to investigate whether opinions of stakeholders in the educational sector differ from one another. The participants in the group of my study was parents, teachers, students, members of the Nigerian Union of Teachers, and the academic staff in the universities. These are the stakeholders in the educational sector, and we try to get opinion from them. Government on educational sector for the past 1 year. Slide 17. The data computed have been preset there for the parents, for the teachers, and we try to segment them, opinion, and gender. On slide 18.
Yes.
My research is updated there that there will be be any statistical significant difference in opinions of the male and female
Very
respondents?
good. Very good.
And my hypothesis states that there will be no statistical significant difference in opinions of the male and female respondents of of each group.
Good.
On slide 9, definitely go say
Yes.
slide 19, 20 to 25, the 6 basic steps to go through SPSS computing chi-square is right there. Based on the final step and get tables out. The tables are shown on slide 26. So
Good.
we can move to slide 26.
Yes.
You see the tables. Depending on what you choose, like so we have to choose squares. We have to go through chi-square test and the symmetric measures. But the major table we have to concern ourselves with is the chi-square test table. That's where values of what we need is shown there. The value is 9, and my signal is at 25. 25 is definitely larger than the significant value that we are taking. So, slide 27, slide 27, and see my friend. To report statistics, you have to state that there is this value showed no statistical significance. In the opinion, male and female respondents of each stakeholders group. Why is it not significant? Because the chi-square value is it not the chi-square value is 10.00. The freedom is 9, and the p value is greater than 0.05. Therefore, the null hypothesis there will be
Hey, hold on there. Hold on right there. Hold on right there. Will you reject this null hypothesis?
not at all, sir.
Not at all. How will you not? It has to be rejected if you look at your p value, which is greater than 0.05. Larry? Yeah, I don't want you to go further. I mean, correct this one. What did you do to null hypothesis?
Not rejected.
Exactly. So there's an error there, big one. Please carry on. A lot of noise, echo. Go ahead. Go ahead, Larry.
Not, yes, sir.
Go ahead. Go
Not
ahead.
rejected. I'm sorry.
Yeah.
Correct that, sir. And my colleagues is kind of correct that.
No problem. Please carry on.
So moving on. Yes, sir. Yes, sir. Non-parametric all of the way. Thank you very much.
Yes, thank you. Thank you very much, Larry. In spite of all the technical challenges, we still managed to make it to the end of it. I'd like to appreciate you all. Can we now take questions for Larry? Let's take questions. Let me tell you the order in which I think we'll proceed. Iroko Ganiu, if you are there, we then take on Fakunle. Yes, Iroko Ganiu. Okay, Fakunle. Miriola Yonju. Stephen Akintolure. Okay, a lot of echo coming from here.
My question is on slide 6.
Slide 6.
The very first sentence. And I would like him to just make an amendment.
Dr. Miriola Yonju, we are not hearing you. Dr. Miriola Yonju, we are not hearing you well today.
There should be a sign of equality. There should be a sign of equality there.
Okay.
Very first, that's on the screen. Yes, Mr. Wallace.
Okay, thank you. Hey, can we let somebody be talking at a time? Dr. Miriola Yonju, are you through? Mary
Yes,
Faith Omoraka. Oh, she's not ready yet. Famuyide.
Yes, sir. I want him to. It's just an opinion that I have about slide 7.
Okay.
Sorry.
Slide 17,
I
yes.
feel that the research question and the hypothesis is supposed to come before that data that he put there.
Of course. They should come before. Yes, they should come before. Yeah, I think he needs to move these other slides, forward. You are correct. Let's see who else. Saibu, can you hear us? If you can ask your question. If not, let's ask Mr. Yeduni. Madam Anigoro,
Yes, sir.
you have the floor to ask. Yeah.
Yes, sir.
Yes, sir. My question is on slide 3.
Yes.
Slide 3. Talking about assumption. Under definition.
Yes. Yeah, you are responding now. Yes, Landry. Yes. Go ahead.
Yes, sir. So the question about from Dr. Tatumbo, I would like to make amendments to that. Thank you very much. And the one noted by Okebukola, how to gain person. I will note that. Question about lesser assumptions. Lesser assumptions means that whenever you have a distribution or a study that has different types of
I like the way you answered Dr. Anigoro. She just said it's okay. It means as if she's not convinced.
Since I'm in the class, I know you will make correction.
No. Okay, that is fine. That is fine. Now, well done, Larry. Although he has done a disappearing act now, we can't see him in class. Oh, he's back. Yeah, that's good. So I think that will be it. Faculty will be presenting. Is it tomorrow? Yes.
Hello, sir.
Yes, I'm here.
Hello, sir. I amended my slide and I'm ready to present. If you allow me.
Yeah, but there's some echo all over the place, so that's the challenge. We'll allow you. I think we can do that tomorrow because there's a lot of echo coming from a number of places. Although it's quiet now. What should we do, class? It's 10:17 p.m. I do not know whether you want us to continue or you want us to have faculty come on another time. Pardon? Yeah, there's quite some noise, so that's why. Faculty, please don't worry. We'll still give you the opportunity to make your wonderful presentation, and we'll take it there. So if you don't mind, let us sign off for today. We've had a very long day. We had some interesting session in class, and I have the pleasure to close the seminar and wish you a very good night. And I'll see you tomorrow. All right. Good night. Bye-bye, everybody.